I'm Gian. I'm a member of the technical staff at Anthropic. And a question I get asked all the time is, how good is AI? Which I think it's interesting, but it's more interesting to ask how fast it's getting better and whether we're maybe possibly even slowing down. One way of approaching the question, which is, I think, pretty deceiving, is possibly to look at the rate of progress of products. So 2022 was like the year Anthropic released Claude AI, and so it's a chatbot, right? You ask a question and get an answer back. All nice and well. Fast forwards 3 years later, you have Claude Code. So like basically Anthropic tackling the software development problem. And finally, this year we have like the knowledge work. So like you drag and drop a folder and you have like Claude helping you work on whatever you do like as an office work. I think that's interesting, but the problem with this framing is that products are fundamentally a lagging indicator. Like you cannot judge capabilities looking backwards, basically. Products are built on top of capabilities. So a possible solution is to look at the kind of tasks that you get to do with these products. So basically 2022 would be, you summarize things. You drag and drop a PDF, and you get to redline it, right? You ask a medical question. You ask a legal question. This was like the era of chatbots. And then you have like 2023, 2024, AIs start to be able of writing code that works, which was like a big moment. And now we are basically seeing AIs that can like do things like running an entire due diligence. But then again, like I think this like framing is interesting because it also captures the signal of like all the startups that are currently building on top of the Anthropic ecosystem. But at the same time, you cannot put this on a timeline where you have like some kind of y-axis. Like how can you understand where we're like accelerating or like slowing down? A possible solution to this problem is asking the question, how long would it take a human expert to accomplish the same thing? How long would it take a professional software developer to write a specific Python snippet that in 2023 models start to be able to do? At that point, this is like solving the problem, right? You can put like models on an x-axis. You look at when they were released, and then look how long they're basically automating work that would have taken like a human expert and an amount of time. And you end up with this chart. This chart, I think, is very interesting. It's a clean exponential. It's doubling every 4 months. A few years ago, it was actually doubling every 7 months. So like the acceleration is accelerating. We have some theories of why that is the case. We don't really know why, though. And the headline here is that the most powerful model in the world right now, Claude Mythos, is capable of running autonomously and accomplishing work that like a human expert would take a couple of days of work, full-time equivalent. Now there are like some technicalities here that I'm like glossing over, but I guess like the gist is that this is like a clean exponential. Now I'm sure all of you have asked yourself the question, when does it stop? When is this like, we all know this. We have like this acceleration phase, right? And then like you go linear, and then you go like segmodal, and like at some point it slows down. I was coming here on my way here, and like I overheard someone saying something like, "Oh, this is like peak hype moment," and like eventually this will slow down. And I agree that like marketing is like that, and you have like typical social phenomena are like that. But my challenge to you, looking at like fundamental model capability, is what if it doesn't? What if we're like nowhere near saturating the kind of like exponential growth that we're seeing? I'll try to first rigorously justify to you, and two, assuming that this will be the case, that we're not slowing down, we're actually going faster, what does it mean? In order to like tackle this from a systematic perspective, I need to go back to science. This team of physicists in 2020 published this paper, groundbreaking paper. And basically, they were like, hey, can we predict what like future model performance and capabilities will look like depending on basically inputs? How much data you feed it with, how long did you train it for, and the amount of compute you use. And they approached it very, very empirically. They trained a ton of models. Every single blue line in this chart is a model that they trained. And they were like, OK, let's see, given like an amount of compute that you see in the x-axis, how, let's say, bad it's at predicting things. So the lower the bad it is, the better it is. So you go down, and things, interesting, magical things start to happen. And they noticed one thing. that is like a straight line there. Now, I want you to take away two things from this straight line. The first thing, it doesn't bend. Like, it's straight, and we don't see like the end of it. So it's not like curving. What this tells you is that like the more compute you put into like models, the more chips you throw at them, the better they do. And like it's as simple as that. It's like a prediction machine. The second thing I want you to take away, which I think is kind of poetic, is that this spans 8 orders of magnitude. Now, typical things that we build, engineering things, societal phenomena, they typically like you 2, 3x them, and they break down. Like there's like no such thing in like an equation that spans 8 orders of magnitude, other than like in physics and like law of nature. So what you have is that like we have a reliable way of pushing these laws down, like making models better, that is feeding this exponential, that is creating products, and possibly artifacts that we don't like even know the shape of. And for the last 6 years, since the moment this paper was published, this like rule has held up. Like this is again not slowing down by any means. The exponential is like still doubling for like the last 6 years. And so like the question like becomes, if this line keeps like being so predictable, what happens if it keeps being so predictable in the next few years? And like again, I really like the idea of like using time. How long does it take an expert to accomplish the same thing that AI is now doing? And so like basically in the last few years, it was about tasks, right? Tens of minutes. You basically ask Claude, hey, like you go to Claude AI and you're like, draft me like a reply to this customer of mine, right? Write me this like snippet of code. All nice and well. I think like we're now transitioning into something that is like qualitatively different, so more like into the projects realm, right? Like if you have AIs that can work the human equivalent of like tens of hours, you at that point have like entire projects, right? You have like, hey, take this marketing claim and run with it. Like build the whole campaign yourself. And I think like this is the kind of like world we're going to get into in the next 6 months and starting from next year. And then like if you project it even further, and again, assuming that this trend holds up, and I hope I make a coherent case why I think that is the case, well, at that point you end up like with AIs that can find like actual kernel of truth for things like causes. You can have things like fix me the churn of this like customer segment. And so you basically have like the human equivalent of a CEO talking to a marketing director instead of like a human employee talking to like a task automation machine. It's like qualitatively different. And the key thing here to appreciate is that necessarily there's some level of unsupervision in this whole thing. Like if we have powerful AIs that can like work for so long, and compress human work of months into like a much shorter timescale, necessarily there's going to be some element where we like have to accept some lack of supervision, which is both interesting, I think, intellectually, but also pretty scary, and I think a little bit unsettling. And that's the key reason why the same people that published the law are actually the co-founders of the company I work for. These same physicists saw like this line. They saw where this was going, and they were like, we need to get ready. We need to get ready because this rule is fundamentally buying us time. It's like giving us the opportunity to be ready for a world in just a few years when like anyone can have like a PhD level that can remember every single paper that has ever been published and can potentially engineer the new pandemic. We cannot afford to like walk into that future with like our eyes shut, and so that's the reason why the company I work for is so much investing in safety. This is not marketing hype. This is quite reasonably trying to build the safeguards for a future that is about to happen. At the same time, though, I really like the idea that this is also gifting us time. This is like an opportunity to like get ready for a world where like that same PhD level with unlimited knowledge that doesn't get like tired can at that point tell us things like how cancer is spreading, or like how can we make batteries that can like hold power for much longer? How is our brain like working? And at that point, like I'm really excited for a future where we can like compress the next 100 years of like industrial and scientific revolution into what I think is going to be a very fun and interesting decade. Thank you very much.